Hello everyone and welcome back. So in this video we will be recreating this artwork from start to finish, from modeling to final texturing with cups. This is part of one of my Mardini entries for day 14, I believe. So the theme is Graffiti in cups. And yeah, should be a fun one. And although it might not look the best image in the world, I promise you that there will be some nice tricks you will be able to learn about. And if you don't learn anything, you can always roast me in the comments. So yeah, let's get into it. So I just saved a new scene and we will do the initial setup in this geo container. So I'm gonna drop a font. We will start with some text to play with. I'm gonna say, you can write anything you want. I'm gonna write cups. And I'm gonna pick here a more bold font. I believe I used Home Bold. Yeah, the Home Bold. And now we need to try to make these look more like graffiti. So I'm gonna resample this, and we will lose the O shape, but I don't mind. I kinda like the look. So I'm gonna resample this quite a bit, or reduce quite a bit the segments. So something like this. And then I'm gonna resample it again, but this time set it to subdivision and 0.01. So something like that. Right away we get a very different look, as you can see. And now we can play with this and get a more pleasing composition. So the first thing I'm going to do is to randomize the scale of these letters. So you can use a for loop and with a transform, but I'm gonna use vex instead. As you can see, we have single primitives, so we can use that to apply per object transforms. So I'm gonna create a wrangle and do the transforms in this wrangle. So I'm gonna get a random value, so float rand, and I'm gonna say rand, oops, float rand. It will be a random of the primnum, of each primnum. We have 4, and we can right away create a seed so we can play with. And I'm also going to fit this so I can change the values easily, and I'm gonna fit it with some fixed values between 1.3 and 2.2. So let's see if we have any errors. No. And now we just want to scale this, so v at p times equal rand, and let's see what that gives us. So that scales up our objects and we can play with the seed, but as you can see, it's scaling from the bounding box center, and we want to scale it from each centroid of the primitives. So for that we will get the bounding box center, so vector bbc, it will be equal to get bbox center, and we will use a primitive group in here, so we can just say I to a, since we need a string, and we can pass the primnum. So now we need to subtract the centroid, so v at p minus equals bbc, apply the transformation, and after it we can transform it back, so v at p plus equal bbc. And now we can play with the seed. In this case I chose a value of 67, so something like that. So there we have our random transformation. We just scale it up and down. And I also want to create here an ID, so I at ID, it will be equal to a primnum. So we get like a class attribute. We can do a connectivity, but while we're here, we can just create this ID. Now I'm gonna do some transformations to this geometry, and it will be easier to do it with packed primitives. At least that's my experience. So I'm gonna pack this, and in order to pack we need a prim attribute to have 4 points. So I'm gonna attribute promote that ID that I just created. So from point to primitive ID, and I'm gonna pack. This will just create 1 point, and we will need a name attribute and call it at ID. So now we have 4. It might be difficult to see. I don't know if I can scale up this text, but yeah, we have 4 prims, 4 points. So now I'm gonna create a mountain, and I'm not going to create noise along vector. I'm following some values, but feel free to play on your own. I'm gonna change the amplitude to 0.33, and now I can play with the element size and the offset. In this case, I chose an element size of 0.15 and an offset of 12 point something. That should give us these results. And now I want to randomize the orientation also. As you can see, they are slightly moved along the z-axis also with that mountain that we applied. But I also want to randomize the rotation. So there might be easier ways of achieving this, but again, I'm going with Vex. So I'm gonna create a wrangle and play with the pack transforms. So I need to generate a random vector so I can rotate to, or I can generate with an attribute randomize, but in this case I'm gonna do it with Vex. So first I'm gonna set the initial orientation. So I'm gonna say vector z, it will be equal to set 0, 0, 1. So this is our initial orientation. The primitives are facing the z direction. So I'm gonna just state that. Then I'm gonna get a random vector, and for that I'm going to say vector, random vector, it will be equal to sample direction cone, since I want to create like a cone around the primitives. And I'm gonna say along the z, and also input an angle. So CHF angle, so radians angle, that's fine. And now we need a U value or a UV value. In this case, I'm gonna use the rands of the PTNum, and I'm also going to create a seed. So I guess that's all. And we can actually apply this to an attribute and be able to visualize it. So v at random vector, it will be equal to random vector. And let's create the seed. I'm gonna set the, let's visualize first the vector. So random vector, and make it a marker and a vector. Can make it, let's see, let's make it red. Can we thicken this? I don't know. Well, now we need to define an angle. In this case, I chose an angle threshold of 45. Now we can play with the seed, and as you can see, it will create a random vector around that cone, so from the z-axis. So in this case, I chose a seed of 25. It's fine. Now we need to rotate it. So for that, I'm gonna get the pack transform. So I'm gonna create a matrix transform. It will be equal to get packed transform, and we just need to pass the geometry and the primnum. I always like to cast it properly. And now we'll create the rotation, so from this z position where our primitives are oriented towards that angle we created. So for that we can just use diagonal. So matrix rot, it will be equal to diagonal from z to random vector. And now if we set packed transform, incoming geometry, primnum, and we will set this matrix. So transform. And now, as you can see, it won't change anything, but if we multiply it with the rotation, we will get the primitives oriented towards that vector. So I believe that's what I did in there. Yeah. And now we can unpack and do some other operations to it. So let's unpack. And now we have the full geometry again. And we can do a simple exploded view. So again, I'm going to do it with a wrangle, just for the sake of, I like to challenge myself to do the hard way, so I can learn something new. But you can play with the default Houdini nodes and probably get a faster result. It's up to you. I'm gonna create like an exploded view, and that's simple enough. We just get the center of each primitives and the centroid of all the prims of the full object, and then we do a subtraction from one to the other. But we needed to do this by each class attribute. So if you check, we have this ID. So let's create that int class. It will be equal to prim 0, and we want to get the ID, and we can pass at prim num, and we are running over points. That's why we need to do this, or we can promote it. But anyways, now we need a centroid. So vector center, it will be equal to get bbox center of the incoming geometry or first input. Now we need the piece center, so vector piece center, it will be equal to get bounding box center, and we need to pass the primitive group, so we will do at underscore id, it will be equal to plus i2a, so pass it as a string, and class. I call it class in here, but anyways. Now we just do a vector p plus equal channel vector scale, and we will multiply it by the center subtracted from, or subtracting piece center. Let's see if that works out. And if we start to play with it, we get this result. I'm going to create like 0.35. That was my idea. So we get something like this. Now, we're almost finished with this geometry setup. Now we will do a planar inflate to create the geometry. So we created this, we brought the letters together. Now we will do a planar inflate. And of course we need to increase the target, or to decrease this target length to 0.05, let's say, to get more subdivisions, and we can increase this to 5, and also output back, so to create something like this. This is NeoWin 20.5, by the way, and we will also need the boundary edges, so we can create seams for our UV flatten. As you can see, we have them there, and now we can do a UV flatten, and by default this will be all stretchy, but if we disable manual layout and introduce the boundary edges, we get something like this. And I guess that we can do a pause in here and be right back. So guys, we're almost done with the SOP setup, but there are still some things we need to do. I want to create, if I disable this and the geometry, hopefully you can see some highlight in here, and I want to create a light source, a fake light source, and create some specular highlight in cops to fake the 3D dimensionality. So for that, we're going to do this in here in subs, but then we'll move it to cops. So I'm going to create a sphere primitive. So this is just like a single point, and I'm going to place a transform, and I'm going to transform it. I'm going to transform it. Let's move it to about 1.5 in X, about 1 in Y, and also move it along the Z by about 1. So we get, this will be our sun, and we will connect it to the second input. So now we want to create those highlights, and there's a vex function for that called reflect. So we just need to get first the direction from the sun to the geometry. So for that I'm gonna create first the center point of the geometry, so vector origin, it will be equal to get bbox center, you know the drill. And now we want the sun position, so vector sun will be equal to point, first input, the position, and can be 0.0, we just have 1 point anyways. Now for the sun direction we can create a vector sun there, and we just need to normalize and subtract the sun from the origin. So origin minus sun, I guess that's how it's done. And now we can just save it as an attribute. So sun there, it will be equal to sun there variable. So, oh, swing, that's funny. Now we can have a look at that sun direction and create a marker vector. And as you can see, it's pointing from the sun to this. And if we move this around, we can change the direction. And now let's do this in subs, but then we will move the setup to raster space. So we can create a reflection vector. So vector reflect, so I'm going to call it like this, and it will be equal to the reflect function between the sun direction and our normals. And then we can just create a dot product. So I'm going to just say vector front. I'm not sure about this. So I just set a constant vector along the Z, but probably you need screen space, but I'm not sure how to get it. So I'm just gonna do it like this anyways. So I'm gonna create a dot between the reflect vector, so reflect, and the front. So now if we look at this spec, we should get the specular highlights. How cool is that? Now we can move it and create all sorts of effects. So, but again, we won't use this. We will just have it here, and we will rasterize, because if we rasterize this in cops, we will get these shading artifacts, and I want to get a crisp result. So for that, we will, instead of calculating it here, we will rasterize it in cops, or create the effect in cops. So I'm gonna just disable this. And what else do we need to do? So right now we have an ID that starts from 0, so 0, 1, 2, 3. But if we rasterize this in cops, the background, there will be an ID of the background that will be equal to the first one, so 0 on the background and 0 on the first letter. So I'm just gonna offset the ID by 1. So I'm gonna say I at ID plus equal 1. And I'm gonna set this to primitives. So this will just offset the ID. And now I need to create also normals, because we will need them. So normals on the points, I believe. Yeah, and then we can create a null. And now let's move into cops. So let's get rid of this ID and call this out graffiti, and copy this and create a cop network. So let's do a sub import and use external and paste it out. Now we will rasterize this, and we won't move these to UVs right now, because I want to create a frontal projection, so I'm just gonna rasterize the position. So I'm gonna rasterize the position, but as you can see, it's clipping, so I'm gonna create a rasterize setup and move this to reference box, scale to fit, and make this 1.8. So that's fine. So this will be our alpha. And now we need a few more things. We will need the UVs, so let's add UVs. We will need the normals, so let's add normal. And we also will need ID, so let's add another one and set it to ID. And we will need lowercase ID. So we have the alpha that will act as our mask. Then we have our UVs, we have the normals, and we have the ID. So as you can see, they don't overlap anymore. If I didn't offset that first ID, I would get the same color in the first letter and the background. That's why we did that anyways. So now we need to create those specular highlights. So for that, I'm gonna take the initial geometry and calculate that vector in here. So I'm gonna create a wrangle and right away set this to geometry. And let's see what we will do in here. So quite a bit of a setup. We will need to rasterize some attributes. And I'm gonna do it in a wrangle instead of... Do we have UVs? Yes. I'm gonna do it in a wrangle so we can avoid some padding issues. So let's stick with this. let's create first a UV component, so can be equal to rel box of the incoming geometry and v at p, and we can reset the z component, so uv.z, it will be equal to 0.0. This will just give us a UV map. And now we can create an XYZ function, or in this case I'm going to use UVDist because I'm more used to it. So int u prime, we need these variables, and we also need a vector UVW. And now we can create floats, udist, it will be equal to UVDist, incoming geometry, so first input, the UV, and from these current UVs, and we will pass we will write to the u prime and to the UVW attributes. And now we can create that magical component, which is the padding. Not passing, sorry, padding. And let's increase the padding to 0.01. Now we can just rasterize in here. So let's add in here an RGB and call it origp. And we can just say v at origp. It will be equal to prime uv first input, and we want the position, and pass the u prime and UVW. So let's see if that works for us. As you can see, it's creating, and we have the padding, which is the most important part to rasterize this. That's why we are using a wrangle. And now we want to get some other attributes. So we will need the normal, but in this case I'm not going to write it, so I'm just going to say vector n. It will be equal to prime uv, and we want the normal. And we also need the sun direction, so vector sun there. It will be equal to prime uv, and I believe I call this sun there. That's fine. Now we need to do that reflection thing. So let's come in here and copy this out, so we can just copy and paste in here. Let's disable the comments, and it will be the reflect between the sun direction and the normal, the front, and the spec. Now we just need spec, and now we need to output this. So sun, in this case I call it sun there. And now we need to create in here an output, so it will be mono and called spec. Let's see if that works, and it does. So that's fine, and as you can see, we don't have those artifacts, and if we increase the resolution, we will get a better result. So I also want to create a mask along the top, so let's do that right away. So f at mask top will be equal to dot between the normal and the vectors, so along y, and if that is bigger than a CHF, so if that is bigger than a threshold, and if we create that threshold, I'm gonna set it to 0.7 something, and I'm also going to copy this and create in here the output, so we should have a mask top, and it will be quite sharp, and you will see how this gets in handy. So now we will need to do something. Let's do that in the next part. So we're making progress here, but still a long way to go. We have the attributes rasterized, and we have those masks, and now we will work in this projected space, let's say, in this flat plane along Z. So for that, I'm gonna need to UV sample that specular map. So spec, I'm gonna sample from the UVs that we rasterized in here. So we should get, in this case, texture sample. And we get, as you can see, the specular highlights. And the same goes for the mask top. So as you can see, we get that mask along the top parts. So for now, I only need this. And my original file is a mess. I'm gonna try to keep some consistency in here. So right now we're going to from this ID, so if we have a look in here, I'm gonna create a random RGB. So I'm gonna pass this as a seed and create a random RGB. And let me see, I don't remember which one did I use, so I'm gonna have to experiment in here. So I believe two-tone, yeah, two-tone, and I set the seed to 31. But as you can see, the background is also visible, and that's because we have this ID as 1, and there's no way, as far as I know, to reset that in subs, but we have this here 0 negative ID, so if we make that background negative somehow, we can avoid having this background issue. So I didn't use this one, I used infrared, yeah, infrared. And now we need to make that background negative. So let's create an opencl because it will be simpler. And right away we have an error because we need to define this as a, let's just do this low effort, just define this as an int and go in here and set this to ID and set this to ID. So that's fine. Now we just need to say, so at destination.set, and we will say if source is equal to 0, so the background. If that is the case, we can set it to -1, otherwise we set it to source. And there we go, we already removed the background. So that was easy enough, and that's a nice trick to know. So that's fine. Now what else we will do in here? Now we will just do... I have some things in here, but first of all I'm gonna create in here a blend. So I'm gonna blend my specular highlights. So I'm gonna change this to background, and as the foreground I'm gonna get the specular highlights. And I'm gonna change this to overlay and change the amount. And as you can see, we're already starting to get that look. So in this case, let me see, I use the value of 0.23, and let's change this to 2K just to have a smoother result. And as you can see, we already get this look of 3D dimensionality, and we will play a bit more with it. So now we will also create some tighter specular highlights. It's hard to follow this file. I have so many things going on, but I'm gonna try to keep it as readable as possible for you guys. So I'm gonna remap and tighten this mask. So I'm gonna set this to 0.7 something and reduce also this one. Let me see in here. Yeah, we still get some issues in here. I guess that's because of the geometry, but we're gonna just blur it anyways. So I'm gonna blur in this case by 0.02 to get this result. And now I believe I added on top, I'm not so sure now. In this case I used an HSV adjust, so HSV adjust, and I'm gonna adjust the colored image by this mask, and in this case I can just increase this quite a bit, and we get that sharp specular highlight besides the default one we already have in overlay, and we start to get this look. We could probably create an outline in here, that would be cool also, but let's keep it like that for now. So I'm also going to create a gradient from top to bottom. So for that I'm gonna get in here this ID and create UV map by ID. I think that's it. So UV map by ID, yeah. And now I'm gonna do a channel extract and extract the green channel, so top to bottom. And I'm going to multiply this with my mask, so I get rid of that background. So I'm gonna multiply this with my alpha, so we get this. And now I'm going to again HSV adjust, but before all of this, so after this one, HSV adjust. Let's see how that looks. So in this case, I'm gonna increase the value to 0.6 something. And if we get this and this, as you can see, it's just adding a bit of color to the top. It's optional, you can try that or do something different. And now we will create some details inside these shapes because I don't want them to look this flat. So for that I'm gonna create an SDF shape, and it will be a wave. I'm gonna set the arc to some value and decrease the element size to something like this, and rotate this 108. Then I'm gonna create a mono from this, SDF to mono, and I'm gonna play with the thickness. As you can see, I'm gonna set this to 0.066. That's fine. And now I'm gonna do a tile pattern. So tile pattern, and I'm gonna connect this to the shape. So now we need to randomize this, of course. So I'm gonna right away I'm gonna set the divisions to 5. Then I'm also going to play with the position offset, so uniform jitter, and set this to 0.16 something. Play with the seed, in this case I chose 35. I believe I also play with the rotation random, so rotate tile, so rotate. I'm gonna set the set bearing and rotate variation to 180 and play with the seeds, that's fine. And now I'm also going to play with the scale. I'm gonna set varying. I'm gonna decrease the scale to 0.661 and increase the variation to 0.5. And now I can just play with the seeds. In this case, I can set it to 0. And that's all I've done in there. So we get this randomized look. And now we will just distort this. So distort. And we will distort this. I will set the scale to 1 and create a fractal in UV space. So in this case I chose a fractal 3D. So fractal 3D noise. I'm gonna set this to the scale to 0.388. So increase it, set the amplitude to 1, center to 0, and set it to UV since we want to displace it in all directions. And now if we can feed this to the there, and we'll get this randomized look. Yeah, this is completely optional, but I find that worked well over my shapes. So now we can just do an HSV adjust in here. So HSV adjust, and we will use this as a mask. And we can just set the value scale to 0 and this one also to, so value shift to 0. And now I'm getting a completely different look because I need to play in here with this noise. Oh, I played with the offset, of course. So let's go in here and play with the offset. In this case, I chose a value of 1080. So we should get something like this, which I think it adds a bit to the overall look. So yeah, let's keep working on the next part. So okay, let's start to work on our background right now. For that, I'm gonna create a fractal 3D noise. This will be quite simple. So I'm gonna set the amplitude to 0.0 something, really low, change the center, and I'm also going to play with the contrast to something like 0.2. increase the size of the noise, and I'm also going to increase the roughness. So this will be enough. Now we can just convert this to RGB, so mono to RGB. And I have some colors that, or a single color that I used is somewhere of green. So it's this color in here, and I'm going to increase these dark spots to something like this. I want to create some leaks. So for that, I'm gonna start with the UV map in texture space. Then I'm gonna create yet a fractal. And in this case, I want to set it to UV, set this to 0, since we want to deform it in both directions. Set this to 0.4 something. And I can also play with the roughness to 0.1 something. So, and now we just need to play with the element size. Let's set this to 0.05. And now we can just add this. So if we add this to the UVs, we should distort the UVs. And now we can create a ramp. And it will be along the y-axis. And we can connect this to the position. And from there, we can just invert this or just crunch the values in here. Something like this. And now it should be, we have this mask, but we need another noise. So I'm gonna duplicate this noise. And in this case, I'm gonna change the element size to 1 and reset the center and these values. Set the element size in here to 0.1 and reduce a bit the roughness. Something like this. Now we can remap this. I believe I changed this. No, it's simplex, that's fine. And we can remap this. And the remapped values will be around 0.3 and 0.8, something like this. And now we can just multiply this by our mask. So if we multiply this in here, we get this sort of result. And then finally we can just readjust over our background. So let's move this in here and create an HSV adjust. And we can just reduce this to 0.225 to something. So in this case, I just want to make sure that I don't contrast this. And I'm also going to change this, not simplex, but to... Oh, in this case, I use the fractal to the noise. Change this. I can just copy this quickly and change this to 0.05. The amplitude to 0.8. The center to 0 and set it to UVs. This should give us a better result, hopefully. So let's see. Yeah, this is more what I had in mind. So if we change this, it will be sharper. And I also want to reduce. I want to reduce the roughness quite a bit, so we don't have this sharp transition. And we can increase or decrease more the effect, and we get this nice result. Maybe we can play a bit more with the remap in here. Or in here. And play in here. So something like this will do. So that's our background. Now we want to blend this. So these will be our foregrounds, these our backgrounds, and as a mask we will use this intrinsic alpha. And now we need to start to organize this a bit better. So something like this. We should get these results. Now we need to figure out the shadow and also the contours. So now we want to create the shadow effects along where it makes sense. So from the light source, so along this direction, from the right to the bottom left. So for that, I'm gonna create in here an edge detect by normal. Yeah, it will work better. And if you remember, we have that normal output in here. So if we input this in here and increase, I'm gonna try to increase the thickness, the line quality to 2, the blurring to 3, and the tolerance we might want to reduce this. So, we want to reduce this to point or something, but still it's not enough, so we can just dilate it. So in this case, what sort of values did I use? A radius of 20, that's fine. Now, as you can see, we have some gray values and whatnot due to the dilation, so we will do in this case, let's maybe move this down in here. Yeah. And we will do an equalize, so to normalize this mono channel, and that should help a little bit. And now I want to move this into an SDF, so mono to SDF. And we get this, and I'm gonna change the iterations to 2. I'm gonna create an SDF adjust, so I can increase or decrease the size. In this case, I didn't play with, I reduce it 0.005, and I'm gonna blur it. So I can get, as you can see, we have this polygon look in here. If we blur this SDF, and in this case, what sorts of values did I use? So 0.025, and now we can do SDF to mono. And of course we need to play with the ISO offset, so 0.05. So this will be our outline, and in this case so this will be our outline. So if we do edges, we adjust and use this, and we can just value shift, start to get our outline. But maybe I don't need to play so much in here with this, or so much blur. So let me see, this is blending a bit, so maybe I can adjust it a little bit further, and now blur it, but not so much, and SDF to mono. Let's see if that helps. Yeah, I need to reduce that value. So something like that. That starts to look better, but still we need our shadow. And for our shadow, we will need to do some things. So we have this, and now I want to create a shadow to extend the pixels, in this case to create a shadow, so like a fake shadow. But I didn't find a solution right off the bat. So in this case I chose opencl to do some operations in a loop and just extend the pixels. It's a naive way, but that works, and hopefully you can get something from this. So I'm just gonna set the layer properties to constant, because I don't want this to repeat. So right now it's repeating, as you can see, and I'm gonna change this to constant so it doesn't repeat. And now I'm gonna create an opencl. I'm gonna delete all of these and delete any bindings. And it shouldn't error out. Now, this will be really simple. It will be like a feedback loop of setting the pixels. But for now, let's create what we need. So we need to bind a layer, which will be our source. And we need to make that writable. That's why we use this and symbol. And we will make that a float. We will also bind the destination. And we can make that optional. And also we will bind a parameter, so parm offset will be equal to float. Let's create that and let's bind the source. Okay, now it's complaining. I probably need to do something in here. What is complaining about? So destination mono, because probably I need to the right back part. So let's just make this no read. Let's continue with the code and this will fix itself. So let's just create the kernel. And we will, in this case, set at destination dot set at destination dot set equals to source. Oh, now it's working. Okay, we need the kernel. And we don't want to do this, but for now we will write the right back, because we will do this in a feedback loop, and it will be, in this case we will set the source to we will set the source with the destination, so we will just feed it back and it shouldn't error out. And now we can actually do the offset. So I'm gonna create float to UV, it will be equal at p.texture. So we will do this in texture space. This will be just our UVs, and I'm gonna offset the X component of the UVs by that offset parameter we have. And I'm also going to offset them in the Y. So in this case, I believe we can just do one line, right? Since we're just adding. So UV times E plus equals offset. And then we can sample, so float sample will be equals source dot texture sample, because we are in texture space, and we will sample the UVs that we just offset. And then at destination dot set, and we will just max the source and the sample. Shouldn't error out, but it will do it. It won't do anything. So we set this to 0.002. Let's see. Did it move? Oh, we need to change this to destination. So let's see. It should have moved a little bit, but now we need to do this in a loop. So in this case, I'm gonna set this to right back and increase the iterations. As you can see, is maxing out the previous layer with the current one. And I'm not sure, I used 15 iterations, and this should be pretty fast, as you can see. So now we can, let's see, we can blend these in here, I believe. So HSV adjust, I'm just using HSV adjust. Probably there are better ways. So I'm gonna set in here and just decrease this to something like this, and let's have a look. Now we have a shadow, but we don't want just a shadow. We want to create some drips in here and blend it and something like that. So we will do that in the next part. So now we need to get back to SOPs to do some scattering of points, mainly on the top of the letters and here on the bottom, so we can create some dripping effect, some fluid like effect. So for that I'm gonna reset this, going back, and I'm gonna create in here. I'm just going to be lazy and copy from here, so from this, and I'm gonna create a wrangle, and we will create two scattering systems. What is going on in there? I didn't see that coming. So let's see. Well, let's increase that to 6.05. Why is it different? Well, I'm gonna ignore it anyways. So we fix that. So now let's create the masks. So I'm gonna create here a mask, and it will be between the normal and the negative y-axis, and if it's bigger than threshold, and we need v at n, and the threshold will be, let's see that mask. This will be for the bottom, so we can just say 634, something like this. So this will be for the bottom, and I want to right away clip this along the y like this, and below the plane, and minus 0.36. And I'm also going to clip by the attributes, so I'm gonna duplicate this clip, and instead of this I'm gonna do mask, and can be primitives above, and increase this to 0.76, and I need to remove the direction. And now I'm going to scatter. So we just clipped by attribute. This is a new thing in Houdini 20.5. And I'm gonna scatter. I'm gonna try to get a similar result, but might not work. So 3 points and a seed of 21. Let me see if that actually worked. It didn't. 0.36. So direction, clip that attribute, and we get, well, let's change the seed. Try to get, let me see. I guess we can clip it a bit more, or change here the threshold, and play with the seed. Well, let's keep it like that. That will be good enough. I just want 1 point on each end. Now we can create a p-scale, attribute adjust floats, and I can just set this to random, and I believe I use random, and a mean of 0.24 and a max of 1.25, and I can play with the seeds. So now let's copy this setup and do the one in here, and now we need a mask for the top. So let's copy this and create one for mask top, and it will be along y. So let's do mask top, and the threshold we can just create another one, and in this case I'm gonna increase this threshold quite a bit more. So I'm gonna clip that mask top, and I'm gonna scatter, in this case, 7 points, and I'm also going to introduce the mask top, and I'm going to play with the scale in here. So just change the seed, and we can probably play with the seed. So let's keep it like that. Now create a null. Out point A and out points B. So that's done. Let's copy this A first. And we want to adjust it in here. Where is our shadow? So let's sub import and import those points. And now we will need to do a bit of a setup. So let's create our shape. For that, I'm gonna use SDF shape, and I'm gonna change this to compound and use egg. I want to create a dripping effect, so I'm gonna set the roundness to 0 and this to 0.4 something, decrease the scale to 0.3 something, and decrease this to around 0.7. So something like this. Now I want to duplicate this, and I'm going to change this to basic line, and I'm going to set the length to 1.4 something, and the uniform scale to 1.1. I'm going to add the thickness, and I'm going to rotate this 90 degrees. And I'm also going to change the thickness in here to 0.06 and 0.09 in here. So something like this, and now we can just SDF blend. Let's see if that works. Well, it didn't work. We need to move this a bit down. Something like this. Now we can blur this. Let me see. Yeah. We can blur this. So the shapes blend a bit better. So I'm going to blur this by 0.18, so quite a bit, and convert this to mono, SDF to mono. This is getting long, so we already get the drip, and I'm gonna place a transform just in case, transform to D. And we have our points, so we just need to stamp points. And I'm gonna input the points and the stamp shape. So we also have that P scale, we might need to play with it. In this case, I'm going to increase the size to 0.2 something. So something like that. That is fine. Now, after our shadow thing, so we can move this back in here, and now we can do something in here. So let's do an add. Well, in this case it's not an add, it's a max. So I'm gonna set this to maximum, and I'm gonna play in here. So I'm gonna set this mono to SDF because I want to blend in here the transition, otherwise it will be too harsh. So if I feed this in here, and we have a look in here, well, how that come? Oh, I don't want to do that. I want this. So what am I doing in here? This is correct. So as you can see, the transition is too harsh. I want to smooth it out. So we can convert this to SDF. So mono to SDF. So we have this, and we do mono to SDF. And it's not working. Great. Do I need to set the layer properties? Let's see. This should work. So mono to SDF. This is a mono, so mono to SDF. And why is not working? Well, it's not working. So I believe I found out why it's not working, because if I invert this, now it is working. Why is that? I wonder why. That's weird. Anyways, let's continue on. That was something I wasn't expecting at all. So let's increase the iterations to 2. Now let's do an SDF adjust. And in this case, we will do an ISO offset of 0.009 and just do a blur to blend in the shapes. So in this case, we will do a blur of 0.02. So as you can see, it starts to blend in the shapes a bit better. And if we do SDF to mono, and let's connect this in here, and we can probably move this in. So let's organize this a bit better. Let's see our result. So maybe we can decrease the size of our line, so the thickness. Let's try that. Yeah, something like this. And we could probably pin this, oops, and go in here. So I believe it's this one. Play with the speed scale. Something like this. And maybe there's also this transform that I need to translate down a bit. So I guess this will do. I don't like this part in here. Maybe we need to increase this again. And my graphics card is complaining about this. So let's decrease this. Not a big fan in here, so maybe we can increase the stamping. But now it's too, one is too big, the other is too small. Let's try to decrease this and increase this and play with the seed. So I'm gonna keep it like this anyways. So that is fine. And now we can continue on the next part. So now let's create drips from the top. So in this top part, we'll just create some splashes of drips, if that makes any sense at all. So I'm gonna duplicate these in here, and in this case will be points B, and I don't think that B scale is good enough, but I'm gonna, in this case, transform these. So I'm gonna pick this one. What have I done in here? So stamp points, and I'm gonna duplicate this transform and connect it in here, and that is fine for now. And now we have this at the top, so let's maybe move this up. This is not very good, but so we have this sample. Let's now sample that mask top. So now we have this. I'm just trying to get this a clean look. So we have that. Now we can create a mono to SDF. Will this work? Oh, we did. That is fine. And let's move this in here. And now we can do the same for this one. So we could also do ID, but it's fine. Now I'm gonna do an SDF blend. So SDF blend. And of course is all off center. So let's pin this and come back in here. And maybe play with the scatter seed. So I guess this will be fine. But maybe we increase this to 8. Maybe 10. Not so much. Let's remove relax iterations. Let's keep this to 8. Maybe relax it, but not so much. And play with the P scale. And let's go in here and we can just... Yeah. This won't work as expected, so we might want so masked up. Let's play with the threshold. I did something in here, but I don't remember what I did to fix that. So let me see. Did I transform it down? Okay, I also reduced the scale in this transform, so let's do that. And make sure to set the layer properties to be constant. So I reduce the scale and move it down. And my graphics card is complaining. And let's ISO offset this a bit more. Maybe not. Let's do it like this and we could probably get away with it. So after the SDF blend, we will do an SDF adjust and maybe that can fix our issue. So this is always a struggle. We need to find the balance. So 0.0 something. And then we can blur this. Let me see how much did I use. So 0.03, 0.03, and SDF to mono. And we can play with the ISO offset. And now it's the time where we need to play with the seed. So with these pins, let's try to get a different result. Why is this one in here? So this is the mask top. I don't understand. Let me check. So clip. Let me see. Clip here. So we have this mask and we have this clip. This scatter. Let's remove this mask. Let's try to see. Okay, now it's working better. But I'm still not a big fan of what it's doing in there. So maybe we can play in here with the size. Yeah. Something like this. And maybe we can also transform it a bit up. Sorry guys if this is coming as boring. I'm just trying to make this look somewhat decent. Oh, okay, this is better. And maybe change the stamp points. So in this case we can just reduce the scale. I guess this is fine. This will be good enough. And from here, what will we do? We will create an edge detect by contour. So edge detect by contour. and this will be our source. That's fine. I'm gonna erode it. So I'm gonna erode this. And maybe around 5. Gonna equalize. That's fine, I guess. And then from here we will create a mono2 ID. That's fine. Now let's create ID UV map by ID. Okay. UV map by ID. In this case, I want to set this to texture space. And we can create UV to mono. And then we will just create mono to RGB. So mono to RGB. And I'm gonna blend in some colors that I have. So in this case, around here, I'm gonna blend this orange color. Just trying to create some shading. And I'm gonna blend in here this one. So let's have a look in here. If we do blend, this will be our background, this shape in here our foreground, and our mask, so STF to mono will be our mask. That's fine. And now we can do an SD HSV adjust and take the contour and decrease the value. So yeah, something like this. And to finish it off, we will just add some splatters of paint. So guys, let's finally finish this. I'm gonna create in here, and this will be quick, I promise. If you're still with me, please comment down below and tell me that you're enjoying or not, or you learned something. So I'm gonna do SDF to mono. I can't, this is too much already. I'm sorry about that. So let's create a distort and create a fractal, can be a 2D. We want UV, and let's distort. Oh, we need to increase the scale, of course, and the element size, and decrease the roughness. Maybe play with the amplitude. I'm not even copying my original file, just gonna do it quickly. And now we need a tile pattern, and we will copy this shape, maybe do this and play with the uniform scale varying. So varying, play with the uniform jitter of the position, maybe reduce the scale, and also of course the rotation. So let's do rotate varying. Is this one? Yeah. So we could probably do the following. If we go to the value and set this to varying and play with the seed, that's fine. And now, where is that random RGB? We can reference copy, Control Alt Shift drag, and if we feed this ID in here, and we could, let's see, where is our background in here? So if we do blend, and we will blend this with this mask. I hope you're following. So that is fine. And maybe we can mask out this because I don't want it on the top. I believe I did something in here to mask it, which was a ramp. So in this case, just create a ramp along the Y, and I want to invert it, something like this, and multiply this over this mask. Let's see. Yeah, that is fine. Maybe let's tighten this. And now just something quick. We can take this one, change the seed, all the seeds. Am I changing the position seed? Oops. Position seed, yeah. The rotate seed and the scale seed. And now let's take this and do an HSV adjust as a mask. And we can decrease the value and also introduce the multiply in here. So this as a background, and let's see, maybe we can oops, what have I done in here? So maybe decrease this. And yeah guys, that's basically it. I will post this file on Patreon. This will be my entry for the graffiti day. Hopefully you learned something from this. This was quite a lot of work to put together. Again, not the most exciting thing, but hopefully you got away with some tips. We even did some opencl snippets and whatnot. That's always fun. In my original file, I had a long strip in here, and maybe we can go in here. We are doing this and play a bit more and change the contour. So I don't want to erode it so much, so maybe it's just 2. So that's better, I guess. And maybe, just maybe, we can pin this and play in here with this scatter seed. That is not bad. Let's maybe just set it on 9. Well, I'm not gonna bother. You just have to play with it and find an happy accident. But you get the idea. We get these drips along the Y and along the top of the graffiti and whatnot. So hopefully this was useful to you. Please let me know in the comments if you learned something. And as always, you can grab the files on my Patreon alongside with hours and hours of exclusive tutorials. I also have some courses. They are pretty cheap and you help to support the channel if you enjoy the kind of content that I'm making. And yeah, let me know in the comments something, what you thought about this video, if you found it interesting. Thank you for watching and I'll see you next time.